In this lecture, we will discuss additional abutment weight, or additional ramp weight. This is referring to the inclusion of the undisturbed soil and the extra ramp walls. So I'll start with the ramp walls. Ramp wall construction, height, and width are discussed at length in the component analysis lecture and in the construction management course. In the construction management course, it's in terms of material estimation, and in component analysis, we're more thinking about the stresses in those ramp walls. So here I've drawn a quick refresher, and remember that the ramp wall thickness is 30, 50, 70, or 40, 60, 70, depending on the max height from the ground level. And this is just for a 3-tier abutment. You can reference the standard drawings for the other ramp wall widths, but I'll use this as an example. We need thicker offset ramp walls to carry loads from the anchor to the foundation and serve as formwork for the ramp fill, which you can see in the section here. In the basic design course, we assumed the entire ramp wall area was 30 centimeter walls. So we took the ramp wall area, we assumed its thickness was 30 centimeters, and that's how we got the volume of our ramp walls. This is numerically a much easier calculation, but wastes a lot of capacity. Or rather, doesn't engage or doesn't sharpen the pencil to think about this extra capacity. So using the level method, from the basic course, I've drawn a example for you here showing that this baseline area, we'll call it area of base, is either 30 or 40 centimeter wall, depending if you're in Eswatini or Bolivia, and that is wasting a lot of extra capacity in terms of weight. So using the level method, we can calculate the extra ramp wall volume using AutoCAD to start. And similar to the note I made in the lecture on uplift, we need to make sure not to forget to update these calculations or measurements when you make design changes. And as a reminder, the level method is what we describe in section 4.8 of the EIA Bridge Binder, volume 2 for design. I find this easiest to break down as follows in my design tool. This isn't the only way, but it is what makes sense in my brain. So what I'll do is I'll measure the following values for a 3-tier bridge. The same should be done for a 2-tier bridge or a 1-tier bridge, but the 70 centimeter area or the 50 centimeter area is omitted for those. So I measure the total ramp wall area, called A base. I'll measure the 50 or 60 centimeter ramp wall area and call that the medium thickness area. And I'll measure the 70 centimeter ramp wall area and call it the large ramp wall area. And remember, when I'm making these measurements, I want to be using this level method, which is described in detail more in the binder, but the basic premise of the level method is we're coming 1 meter down from the top of the walkway hump and then just taking a level across. We're going 1 meter down from where we previously took 1 meter and going straight across. That's our 50 or 60 centimeter wall. And then whatever is remaining is that 70 centimeter wall. And that's why you have this dimension when we look at it in section here as varies. All right, going back to the values that I've calculated in AutoCAD using the area function. I'll next multiply in my design tool the total ramp wall area by 30 centimeters or 40 centimeters to get a baseline ramp wall volume. Then you can multiply the medium ramp wall area by 0.2 to get a medium ramp wall volume, and the large ramp wall area by 0.3 or 0.4 to get a large ramp wall volume. And with these 3 volumes, we can calculate weights. The basic ramp wall weight, this is what you would get in BP211, and this is what you would be using for your entire design in this case if you're just doing the basic course. Then we get our medium ramp wall weight and our large ramp wall weight. The summation of these two is our additional ramp wall weight, and then we can have the equation that our total weight of ramp wall is going to be our basic weight plus our additional weight.